Next we have Dennis Bushnell, Chief Scientist at the NASA Langley Research Centre. Now, Dennis's bio is in the programme. It's extremely impressive. I could not remember it. I would have to read it. But rather than doing that, I would just like to say that I heard Dennis being interviewed by Gwyn Dyer, who wrote a book called Climate Wars, which also had a CBC radio documentary for the Ideas show. And I heard Dennis interviewed, and I went back to the original interviews and I listened to them over and over again, because I had never heard anybody with such an encyclopedic knowledge across such a broad range of areas on some highly innovative, radical ideas. So I invited Dennis to speak, and I was delighted that he accepted the invitation, and looking forward to hearing you speak. Thanks, Dennis.
Okay, if I could put up the first chart, please. Okay. For the past day, you've been hearing about tactical water. I'm going to describe strategic water, the frontiers of the responsibly imaginable, how to fix water, and so let's get with it. This is some intro. We evolved over the past million years, the humans, the dominant animal on the planet, as superb hunter-killer groups, and nature provided. About 10,000 years ago, we controlled nature in terms of plants and animals. In the agricultural age, and this literally enabled civilization. Starting about 1830, we mechanized agriculture, and we went in this country from 97% of the workforce being subsistence farmers to now less than 2% are farming. The current IT bio-nano age, we're automating industry and agriculture. In 1950, 60% of the workforce was manufacturing. Today it's 11%, heading to 2%. And we've already started into the roboticization of IT bio-nano industry and agriculture, i.e. technology really matters. The humans have taken over in vastly shortened evolution. The human engendered evolution, which is going on now, is 10 million times faster than any natural evolution. For better or for worse, we're now in charge, although there's no plan, of the evolution of the planet, of the evolution of the human species in terms of genomic design and repair, designer children coming along, and designer life forms. In terms of the climate, the IPCC estimates based on really solid science is by 2100, 5 to 6 degrees C and up to 2.6 meter ocean rise. These estimates are proving to be hideously conservative. They said in the 07 IPCC that we would have an ice-free Arctic in the summertime by 2100. Based on the way the ice has been melting over the past 5 to 6 years, this has dropped from 2100 to 2040 and now to 2014 to 2018. Obviously, we really don't know what's going on. There's greater than projected worst case CO2 rise. The oceans are warming much faster. The ocean acidification is 10 times faster. We're turning the oceans into weak carbonic acid. What's not included in the IPCC estimates, what makes them so conservative, are positive feedbacks. These are not included because we, NASA, we NOAA, we the world scientists have not produced the detailed data sets necessary to put this on a really solid science basis. These positive feedbacks include the fact that there are massive amounts of fossil methane in the tundra and in the ocean. There are melt lakes the size of France and Germany combined in Siberia, out of which the methane is bubbling so fast it won't freeze. There are methane releases in the ocean off of Santa Barbara, currently in the Bering Strait. And this methane is 22 times worse than CO2. And in fact, the current natural gas, the way we're now ripping it out of the earth, is producing more climate change than coal extraction because of the methane. There's vast amounts of CO2 in the tundra soil in the ocean, and the tundra is warming much faster than the rest of the planet. There's reduced ocean CO2 uptake. It's down around 26-28% due to temperature increases, acidification, and algae reductions. And you might be interested in what happened to the algae. It turns out that to solve the Dust Bowl problem, we planted winter wheat. And that stopped the transport of iron-rich dust over the North Atlantic. The Chinese are planting winter wheat and in their hinterlands, and that stopped the transport of iron-rich dust over the North Pacific. And algae absolutely requires iron-rich dust to grow. We have 14 times taken ships out in the ocean, dumped iron-rich dust overboard, and the NASA overheads watch these magnificent algae blooms. And right now, there's about 26-28% of the algae is gone. There's further albedo changes as the ice melts, and as everything warms up, there's further water evaporation, and water is the worst greenhouse gas. With these positive feedbacks, not to anywhere near the precision of the IPCC, but there are some guesstimates. By 2100, instead of 4 to 6 degrees, it's 12 to 14 degrees C. At those temperatures, somewhere beyond 2100, maybe 2130-ish, some have opined, all the ice melts, including Antarctica, which is where all the ice is, and the seas come up. This is just geometry, about 75 to 80 meters, which would affect about a third of the world's population. Also, both the IPCC and these other estimates indicate that the ocean circulators drop, and therefore the oceans go anoxic. The anoxic oceans then enable the overgrowth of anoxic bacteria, cyanobacteria, which produces vast amounts of hydrogen sulfide, which makes the atmosphere unbreathable and toxic and goes up and takes down the ozone layer. And we're currently losing an area of the ocean equal to the state of Texas each year now due to anoxic conditions, so that's already started. We've had 5 massive die-offs in geological age. The latest was the KT extinction, which is the asteroid into the Yucatan. The other 4 were warming events. The worst was the Permian extinction with 90 to 94%. This is called the Great Dying. This was triggered by massive Siberian volcanoes, the so-called Siberian traps, releasing fossil CO2 at rates 1/100th of the current anthropogenic CO2 release rate. So we are now replaying the Permian on steroids. What people, and all of the feedbacks that I just indicated are all in the fossil record from the Permian. There's a great book, Under Green Sky, by Peter Ward that you might want to look at for this. People worried about the fact that this huge amount of fossil methane in the continental shelves will burp as it outgasses and create undersea landslides that create tidal waves. The estimates for the fossil methane off of the Carolinas are that that tidal wave could well kill about 20 million people on the U.S. East Coast. And then there's the very rapid glacial melting. Many of the world's major rivers, including most of the Asian rivers, rise from the Himalayas, the Asian rivers. This includes the Indus, the Ganges, the Brahmaputra, the Mekong around to the Yangtze. The Yangtze is now dry in the summertime. In fact, it's dry now, causing China great consternation. This will affect, as these rivers dry up, about 1/6 of the planet's humans, and this is in decades. The rationales for going green, the escalating price of petroleum, I'll get into that a little bit. Warming, which is not good. Floods, storms, disease, ocean levels, drought, species extinction, tidal waves, ocean acidification, and so forth. The Middle East oil wars and all that, and the fact that about half of our $600 to $800 billion balance of payments deficit is oil. The conventional energy outlook, peak cheap oil was 0809, where we were producing about 87.5 million barrels a day. We're now pumping, people tell me, below 80 million. The demand is rising. We have 750 cars per 1,000 population. China has 20. China is now producing more cars than the rest of the world. And as the Asians in their billions buy all these automobiles, the oil is not there. The costs are going to go crazy. Peak cheap uranium, the price of uranium is going way up unless you go breeder and thorium. Peak cheap uranium is 2025-ish. Peak cheap natural gas is 2030-ish, 2035. Peak cheap coal is now 2045-ish. And if we force coal to geologically sequester CO2, that'll price coal above the major renewables. Currently, worldwide energy use is about 315 exajoules on fossil carbon, petroleum, natural gas, and coal. That's about 81% of our use. So we need to replace 315 exajoules to get off of fossil carbon. Each of the major renewables, biomass, this is burnt biomass as well as biofuels, drill geothermal, hot rock geothermal, solar thermal, solar photovoltaics, and wind has a potential of 4,000 to 5,000 exajoules each one, compared to the 315 we need to get off of fossil carbon. We're awash in energy, no pun intended. So, suggested green energy best ways forward. Seawater agriculture, this is where you use halophytes, which are salt plants, and you plant those on deserts using seawater irrigation, and I'll get into that. Also, aquaculture, algae is hideously expensive, but cyanobacteria, as I'll indicate, is looking really good as heavy fuels to replace petroleum for transportation. Drill geothermal, hot rock geothermal, burnt biomass. After you extract the biofuels from the biomass, what's left you can burn and produce electricity. Solar thermal, nanoplastic photovoltaic, some of which is now selling for 30 cents a watt, and the efficiency is coming up nicely. And then wind to replace coal, and then the wild card, which I'll get into later, is low energy nuclear reactions. If you want to buy some stock, I suggest Joule Biotechnologies. They came out with an engineered cyanobacteria microbe which utilizes atmospheric CO2, sunlight, and wastewater to produce a projected 20,000 gallons of fuel per acre year at $50 a barrel. Petroleum is now $100 a barrel. This is a no-brainer. The ecosystem appears to be crashing. Freshwater shortages, you people know that, that's why you're here. Species extinctions, the emergence of fragile human-engendered monoculture biomes. There's the climate change stuff, pollution of all manner, deforestation, loss of topsoil and wildlife habitat. The humans are practicing anti-terraforming, where terraforming is what you do to make the ecosystem more salubrious for humans. In fact, prevention of collapse of the ecosystem has now become the overwhelming issue. Current food production is based on freshwater plants, i.e. glycophytes. We're running out of fresh water, as you know. The code word is sustainability. The crashing of the ecosystem is due to population growth and the way we're now living, our standard of living. The estimates vary between 30 and 50% of a planet that we're currently short to sustain the standard of living and the current population, much less the population growth. As the Asians and their billions come up, as they are at 9 to 11% growth rate to Western standards of living, we're going to be short 3 more planets, and they're not readily available. This will result in peak everything. This will result in standards of living plunging. There's a partial solution to this, and that is to switch to halophyte salt plants grown on wastelands and deserts using saline salt water. 22 nations are doing this. This literally solves, as I'll get into, land, water, food, energy, and climate. In fact, just a goodly portion of the Sahara, we've done the sums, this works out. The net return on investment is close to 150% a year. Just a goodly portion of the Sahara is capable. If you take the Sahara, you plow it up, you irrigate it with the Mediterranean, and grow halophyte salt plants, which is the other part. There's glycophytes, freshwater plants that you all think about when you think agriculture. Then there's the 10,000 other part of the plant kingdom, which is the halophytes. You can grow just on a goodly portion of the Sahara sufficient biomass to replace all the fossil carbon fuels, to provide petrochemical feedstock for all the plastics anybody wants, and grow enough food so everybody gets to eat, and return some of the 68 to 70% of the fresh water that's now used for conventional agriculture, as advertised, solves land, water, food, energy, and climate. So this is Malthus 101. These innate ecosystem restrictions and shortfalls will necessarily shift world econometrics from a growth mantra to one of sustainability, with possible population control instigated along the way that changes everything. After the recent economic burp, people want to see the growth business reinstituted. It's not clear that's going to happen. The fact that we live on this very constrained planet has a vote in all of this. Water scarcity is now the single greatest threat to human health, the environment, and the global food supply. The fresh water, 68-70% I heard this morning for agriculture, 15% for industrial, and 15% for household. If you want to solve water, not play with water, but solve water, you've got to attack agriculture people, okay? And we saw in these various presentations that most of the investments and most of the patents are going into one of these 15% things, okay? You're not going to solve water doing that. You may make some money, but you're not going to solve water. We could, via genomics, via careful engineering, via corrosion solutions to enable seawater cooling, policy law changes, changes in lifestyle and diet, pollution abatement, we could reduce much the freshwater requirements for humans, possibly as much as 50%, okay? But the population growth will eat that up, okay? We have got to do something seriously different to fix water. Some 97% of the water on the planet is saline salt water. Much of the rest of it is tied up in Lake Baikal and the Great Lakes, okay? The amount that you people are futzing over in what you've been doing here today is really a little tiny piece of the water on the planet, okay? And we're basically polluting and all the other stuff that little bit. 97% of it's saline salt water. The thesis of what I'm going to go over with you here briefly is that a major solution of this is to utilize saline salt water via halophytes for food, fodder, and energy, and via really advanced energy I'll get into for desalinization. I'm going to suggest that we can do desalinization, don't have to be as energy efficient because there's other ways to do energy. Conventional wisdom is that saline saltwater incursions is really bad for agriculture, and it is if you persist in this conventional mindset that we're going to do glycophytes freshwater plants. Saline saltwater agriculture is a viable to desirable alternative to conventional agriculture. 97% of all the water is seawater. We're not going to run out of it. Seawater contains, interestingly enough, a wide variety of important minerals that are essential in the U.S. diet, the human diet, and is missing in much of our food because we're growing food on land that we've totally worn out, growing glycophytes. Seawater also contains 80% of the nutrients required for agriculture. And I'll have a note on how we can work the nitrogen problem. Alternative seawater ag ways, you can do desalinization, it's a bit expensive. You can use the cold, deeper ocean water by heat exchangers to precipitate moisture from the atmosphere. This is not efficient enough. You can do seawater greenhouses, or you can just plant halophytes, and it's the plant halophytes one I like. And if we did massive seawater agriculture on the Sahara, say, this does positive terraforming, because when you do massive irrigation like that, you make a cool, wet surface that increases low-level atmospheric instabilities, and you incite storms and rain. So you turn the salt water into fresh water, you put rainfall back in the Middle East, and you stop the desertification of the sub-Sahara. There's huge precipitation increases up to 91% due to irrigation. Jensen was superb in the halophyte business. He's recently deceased a couple years ago. He wrote a lot of the resources for this. There's 10,000 natural halophyte plants. There's huge areas worldwide where we have pumped up saline aquifers and tried to grow glycophytes, and in the process salinated the land anyway. And then there's there's 44% of the land mass worldwide is deserts and wastelands, which is absolute great places to grow halophytes using seawater agriculture. These are the countries that are currently have saline ag projects going on. There's 22 of them. I'm working with Nina Fedorov, who is Hillary Clinton's science advisor, on doing halophytes. We have a project in Egypt. A friend of mine has a massive halophyte project starting up in the United Arab Emirates. Working with a lad who has stimulus money who wants to pump seawater out of the Sea of Cortez, Baja, over the hills into the Salton Sea to rehydrate the Salton Sea and to grow halophytes on Indian tribal lands to the east of the Salton Sea. There's a lad who has farms in northern Mexico that we're currently converting the halophyte Salicornia into airplane fuel. The Chinese have done genomic modifications on wheat, rice, corn, rapeseed, and tomatoes. They are growing these on their beaches and on their salt marshes using seawater. The Chinese have a 1,000-year planting cycle. The Japanese have 140 years, and the U.S. is anywhere from 3 months on the street, which is the quarter, and Wall Street, to the 4-year presidential planning cycle. The U.S. is terminally tactical as opposed to strategic. For centuries on the Indian subcontinent, there has been a very successful saline brackish water agriculture for food and fodder. There's a wonderful report on all of this published around '94 by the National Research Council in the U.S. This is referenced in a paper which either, if you send me an email, I will send you, that I wrote for a State Department meeting in Cairo a couple years back on what to do about North Africa. And this was published by the Cambridge University Press. And this NRC report is a reference in that work, which I sent to the organizers. Halophyte farming has been conducted for many years in this country, down in Arizona and other places, with no noticeable salt buildup. The sandy soils, the salt just kind of leaches down into the soil and goes away. The potentials for enhanced halophyte plant growth via nano-biotechnology is thought to be large. People have produced 60% improvements thus far, only beginning. A very important capability is to put into the halophytes the trick from alfalfa and soy, which is to take the nitrogen out of the atmosphere instead of putting in nitrogen fertilizer, and that ought to be doable, people tell me. The ongoing research areas for halophytes enhance plant growth rates and enhance salt loving, reduced water nutrient requirements, irrigation efficiency, plant tailoring for particular bioconversion, refining processes, and ways to avoid freshwater or aquifer contamination. These are the places that are suitable for halophyte biomass production. I'm working with the Pakistanis. They have a not very high plateau near their seacoast on the Arabian Sea, which is perfect for halophyte. When we did the estimates for the Sahara, we took into account the fact that the average Sahara altitude elevation is about 265 meters, so we included the cost of pumping the seawater up to that altitude. I'm working with people from Texas A&M on what to do with West Texas as the oil wells dry up. It turns out West Texas is underlain by the Agua Aquifer, which is one of the largest in the world, which is largely saline. And so people are thinking about growing halophytes in West Texas. There's all kinds of, 44% of the land worldwide is wasteland. Thus far, we've talked about halophyte and seawater ag on deserts to solve land, water, food, energy, warming, and get back to 68% of the fresh water that you people are not addressing. Next, let's look at frontier energetics for desalinization. There are three emerging energetics approaches with the capability to provide, I think, cost-effective desalinization. One is, if we did all of this biomass with halophytes, we'd have plenty of energy to do desalinization, and it would be really cheap. The second one is the fact that people are doing nanoplastic photovoltaics with ever better efficiency, and I have seen proffers for 30 cents a watt, okay? That's really cheap compared to $8,000 a kilowatt for silicon photovoltaics. Then there's LENR. LENR is low energy nuclear reactions. This was originally dubbed cold fusion about 21, 22 years ago, Hans Fleischmann. It was an experimental discovery with huge replication issues and no acceptable theory. They said it was fusion. The fusion theorists went and wrapped themselves around the light pole and said absolutely not, and the fusion theorists were exactly right, this is not fusion. We have had 2 decades of massive worldwide data collection on this. The experimentalists have kept doing this. They have continually increased how much energy for how long and the replication and so forth. And now even the Department of Energy says, yes, verily, this is real. The question is what this is. The Italians in January, February, March, and April of this year did experiments producing 15 kilowatts for up to 18 hours routinely, easy on and off. There's now a viable theory from '06 by Woodham Larson that indicates it's not hot fusion, it's not fission or fusion, it's weak interactions, it's beta decay, fully explicable by the standard model of quantum mechanics. In the Italian experiments, you might be interested, what they're burning is nanopowdered nickel with a little bit of hydrogen to get protons, and they're producing copper and helium-4, okay? So if there's a copper shortage, as we burn the nickel, we can produce copper. This theory has been used to tune this up. We Langley have some IP on this. We've used the quantum theory to optimize this at the right resonant frequencies. And there are no radioactivity issues. There is no radioactivity either during operation or as waste. The Woodham-Larson theory relies on the weak nuclear force. The theory combines quantum electrodynamics, condensed matter theory, nuclear and plasma physics, and chemistry. And it produces low momentum neutrons, so there's no Coulomb barrier. So the water endgame, saline, saltwater, agriculture for food and biomass, and for petrochemical feedstock and fuels on wastelands and deserts that solves land, water, food, energy, and climate. Desalinization via nanotech and energetics for other than food and energy. And serious water conservation, which, yeah, we can do it, it'll help, but it's like conservation for the energy problem. It's about 30% of what you can do, and then you really have to solve the problem. However, using energy to do desalinization brings in an interesting issue, which is second law of warming. Most of you probably never heard of this. There's an excellent paper by Keynote on this. I ran into it and developed it for a meeting at the Foundation for the Future a couple years ago on energy for the next 100,000 years. This is the fact that as you produce energy for human use, the second law of thermodynamics says, with the Carnot cycle efficiency and the rest of it, you have to reject waste heat. We're now producing enough energy for humans so that we're a couple of orders of magnitude away from producing enough waste heat so that the planet has to warm to radiate this heat to space, okay? This is peripherally related to the CO2 problem in that that modifies it, but this is a whole new warming problem, okay? The current measure of the wealth of a society is kilowatts produced per capita. This is not good. The second law warming restrictions will eventually, and in general, not perhaps within our lifetimes, but within your children's or grandchildren's, the way things are going, will mean we can't generate energy from things that generate new heat, okay? Solar incident on the planet, you can do anything you want with that, and there's all kinds of ways to harvest solar, tidal, terrestrial solar, hydro, photovoltaics, wind, and so forth. Even people are now using solar to take CO2 out of the atmosphere, and with the solar energy, strip off an oxygen to get CO, carbon monoxide, which is a fuel, okay? And then you can modify that into hydrocarbons. But anything else that produces new waste heat, and that would include fossil fuels, any kind of nuke, LENR, fission and fusion, drill geothermal, because that brings up new heat out of the interior of the planet, and space solar. We could not do that if we get to the point where second law warming is a problem. The final last resort solution is instead of raising the bridge, we lower the river. Genomically modify the biota, including us humans, to take the heat. We have ongoing studies of extremophiles, biologics in deep ocean vents and deserts and the Yellowstone pools, plus the ongoing biorevolutions, genomics and synthetic biology that proffers the very real possibility of designer life forms, including humanoids, capable of thriving in whatever mess we make of the planet. Okay? The other time scale here is that we have looked at what it would take to terraform Mars, and it would take about 120 years. There's enough water under the poles on Mars, under the frozen CO2, to put an ocean on Mars. A reasonable depth ocean. Not that deep, but reasonable depth. And so we could then put stuff in this ocean that grows and produces oxygen, and so we could make a breathable atmosphere. We still wouldn't have the vanillin belts to protect us from the radiation, but at least we would have some kind of an atmosphere to protect us from some part of the radiation. But that's only one planet. We're going to need 3, okay, within 40 or 50 years. And it would take 120 years to terraform Mars, so this is not going to work. So last chart. Comments with respect to radical innovation. This is a quote. The battle is within. It's a cultural. Between glorifying the past or marching toward the future. Between protecting successes or cannibalizing, between embracing risk or not. The battle is for the soul of this industry and everyone in the U.S. and the future of humankind. As I said, the U.S. is terminally tactical, okay? We have lost it. I have a brief which I'm going to give up in Boston at the complex solutions meeting up there the 1st of July. And I gave it last year at the World Future Society as the plenary, and it's entitled, "Where is it all going?" In which there's an explication of the 7 existential threats to the humans, of which I've only discussed 1.5 of them here in this brief because he wanted a water brief, so I gave him a water brief. I mean, we are really seriously mucking ourselves up. In terms of employment, just as an example, we are in a jobless economic recovery. There's about 7 million jobs missing. Some of them were globalized and offshore, about a third. The rest of them are gone. The code word is productivity improvement, which is a code word for ever better automation and robotization. If you look at the way the robots are going, human-level machine intelligence from the IBM Blue Brain project is now about 10 to 15 years out. Via biomimetics, where they've nanosectioned the neocortex, and they're replicating in silicon, okay? And they're having great success at all of this. So this is not soft computing, this is biomimetics. We have looked 20, 30 years out with the way robotics and automation and machine intelligence is going at what jobs the machines cannot do. The answer is none. We thought we need human touch labor in nursing homes for a while, but the Japanese 2 years ago put robots in nursing homes, and patients like them much better than the humans. The machines are creating wealth within the strictures of the ecosystem capability. The machines are reducing costs, okay, producing wealth, but the humans increasingly can't compete. I have a friend, Steve Thaler, who has developed an imagination machine, okay, which is a neural net which he trains and deprives of all rational input, and this neural net sits there and dreams like people dream, producing new ideas 24/7, 365 on milliwatts, and he has a critic neural net sitting in the weeds recording all of these new ideas and checking them out for various problems and metrics. This thing has produced better toothpaste for Palmolive, it has produced better warheads for the Air Force, and it produces far more ideas, far faster and cheaper than buildings full of people, okay? So, along with all of the other jobs which the machines are, and you know, I've got charts on this, okay? I have tracked which jobs, which have gone, which ones have come in. There's a magnificent book on this called by Martin Ford. It's called Lights in the Tunnel, okay? And if you can sleep well after reading that book, okay, then you're not quite as sensitive as maybe I thought you were. I mean, you know, what people will do all day is not clear. What we're doing with these, and this is only one of the 7, okay, is that the machines are taking the jobs, and the humans increasingly can't compete. We're also becoming cyborgs, okay? We have cochlear implants, artificial retinas, artificial hearts, direct brain to prosthetic limb communication, and brain chips. We put brain chips into about 10,000 people. It affects congenitally defective brains. DARPA's working on brain chips or super soldiers. 15, 20 years out, if you don't have the latest chip in, you can't compete, particularly with the machines, okay? So we are merging with the machines, okay? There's some really massive effects of the IT, bio, nano, quantum energetics tech revolutions that are now on a double exponential, okay? And water is kind of an industrial age thing that's trying to latch on to the IT age, okay? I saw a lot of footprints of that kind of gestalt, okay? There's tremendous opportunities here. But you really need to keep your antennae up, okay? And to check your 6 and to figure out and read as widely as you can. And if you want to check where the frontiers of this kind of thinking is, read Ray Kurzweil, right? The Singularity isn't here, 0506, and then he's now got a movie out, he's got all kinds of stuff. I've been tracking Ray's stuff for about 15 years. He wrote earlier books, The Age of the Spiritual Machines, and a whole bunch of other stuff. Ray has been right on it for 15 years, okay? He's one of these chartists, okay? It doesn't work in Wall Street. There was a bloodbath on Wall Street today, but it happens to work on this, you know, future business. And so there's a lot more out there on the frontiers in a strategic sense than maybe you think about in your philosophies, people. But I understand that you still have to eat. You're trying to sell stuff for tomorrow, and that's why you're tactical. But it's really fun thinking about this other stuff. Thank you very much.